System of particles and rigid body. System of particles and rigid body. Question number part problems 1. Part problem set 1. Question number 4. Two bodies of masses 1 kg and 3 kg have position vectors I cap plus 2j cap plus k cap and two bodies of masses 1 kg and 3 kg have position vectors I cap plus 2j cap plus k cap and minus 3 I cap minus 2j cap plus k cap respectively. The center of mass of this system has a position vector. Center of mass of this system has a position vector. Option A, minus 2 I cap plus 2 k cap minus 2 I cap plus 2 k cap. Option B, minus 2 I cap minus j cap plus k cap minus 2 I cap minus j cap plus k cap. Then option C, 2 I cap minus j cap minus 2 k cap. Option D, minus I cap plus j cap plus k cap. use the formula to calculate the center of mass of the two particles. That is capital R equal to M1 R1 plus M2 R2 divided by M1 plus M2. Use that formula to solve the problem. What is M1? 1. M3, M2? You haven't written 3. So use simply this formula. This is a very simple problem. Just you have to put the masses and the position vectors to calculate the final position vector of the center of mass. Okay, and option B will be the correct answer. Just put the values of the R1, R2, M1, M2 and you will get your answer. Write down next question. Question number 8. Two particles which are initially at rest. Two particles which are initially at rest move towards each other under the action of their mutual attraction, if their speeds are v and 2v at any instant, if their speeds are v and 2v at any instant, then the speed of the center of mass of the system will be, the speed of the center of mass of the system will be option A 2v, option B 0, option C 1.5v, and option D v. D options. Option A 2v, option B 0, option C 1.5v, and option D v. Why?
Because two particles are initially at rest, so the velocity of the center of mass is 0.
Initially, but after certain time when their velocities are v and 2,
No external force on the system.
correct. There is no external force on the system. That's why center of mass will remain at rest. Option B is correct. So remember, center of mass, if it is initially at rest or if it is moving with a certain velocity and anything happens inside the system but there is no external force, velocity of the center of mass will remain unaffected, because their mutual interactions are considered as the internal force when you consider them as a system. So center of mass will remain at rest. Now can you prove this one, that this center of mass velocity will be 0? This is from the argument, this is from the logic, but if I ask you to prove this one, this can be proved from this. If I write this equation in one dimension, what it will give you? X xcm equal to m1 x1 plus m2 x2 divided by m1 plus m2. Okay, if it is moving along a straight line, then only one dimension we will take. Now consider here, if I differentiate both sides of this equation, we get dxcm dt equal to m1 dx1 dt plus m2 dx2 dt divided by m1 plus m2, right? Because mass is constant, so derivative will be on dx1 dt and dx2 dt. Now you can write this one as VCM, that is equal to m1 v1 plus m2 v2 divided by m1 plus m2. Okay, now can I write this one as this one? But in that case, this will be dVCM. Means we are again differentiating both sides. Or you can also skip this dt from here and write it over here. Write this dt on that side. Okay, so again we are differentiating once. Then what we will get here, this is the force on the first particle, mass into acceleration of the first particle. So that is the force on the first particle. Force on the first particle is given by second particle, so we can write it F12 This is the force on the given by first particle. And according to Newton's law, if there are mutual attraction, we know that F12. So take this one on that side. So F12 plus F21 will be it shows that dVcm ddt of Vcm is 0, means Vcm equal to constant. So whatever its velocity is before, it will remain same. So if it is initially at rest, then finally it will be at rest. If it is initially moving with a certain velocity, finally it will move with the same velocity. So velocity of center of mass remain unaffected, while only internal forces acts. Okay. So it comes from Newton's third law. Newton's third law asserts momentum conservation. Always remember that Newton's third law will give you the linear momentum conservation as well as conservation of the velocity of the center of mass, because center of mass and momentum conservation are analogous principle. You can explain any problem, any situation which can be explained by linear momentum conservation. The same problem can be explained by conservation of the center of mass also. These are same principle actually. Question number 9. Two persons of masses 55 kg, two persons of masses 55 kg and 65 kg respectively are at the opposite ends of a boat. The length of the boat is 3 meter and its mass is 100 kg The 55 kg man walks up to the other man If the full stop, then write if the boat is in still water, the center of mass of the system shifts by option A 3 meter, option B 2.3 meter, option C 0, option D 0.75 meter. What is net force on the system? External. Net external force? No. 0. So net force 0 means linear momentum is conserved. What is the initial linear momentum before no one is walking? 0. Then finally it should be 0. So sum of these two momentum should be 0. It shows that dxcm dt. So xcm so what is the change in xcm? 0. So this one is the equilateral triangle ABC, and it is said that three forces are acting. One is acting along AB, that is F1. One is acting along BC, that is F2. Third one is acting along AC, means like this, F3. You can also draw it along this, no issue. Okay. Now, this is the centroid, means from each median the distance of the point O, that is centroid, is same. Perpendicular distance from each median will be same for equilateral triangle. Then we can consider that this distance is R, this distance is R, this distance is R. For other types of triangle, these R's are not equal, but for equilateral, these are always equal. Then calculate torque for all will be 0 about O. Now see, about O, this force try to produce a torque which is in anti-clockwise direction. Check, this is R, so R cross F, it will try to rotate like this, means in anti-clockwise. Anti-clockwise torque is taken as positive. So R into F1, because these are perpendicular, so sin 90 will come, sin 90 will be 1. So R into F simply. Then torque for F2 about R, that is again anti-clock. R to F, it is showing anti-clock, means plus R into F2. But torque for F3 will be clockwise. Check, R cross F3. Okay, so its rotation is clockwise torque is negative, and sum of the torque is given. Then what is the F3? F1 plus F2. Question number 6. The instantaneous angular position The instantaneous angular position of a rotating wheel is given by the equation theta equal to 2t cube minus 6t square, 2t cube minus 6t square. The torque on the wheel becomes zero. The torque on the wheel becomes zero. At option A 0.5 second, option B 0.25 second, option C 2 second, option D 1 second. D.
Sir, option B.
Option?
Option B.
Theta is given, calculate alpha by differentiating it twice with respect to time. Alpha means angular acceleration. Torque will be 0 if angular acceleration is 0, because torque tau equal to I alpha. So setting alpha equal to 0, you can find time. Because moment of inertia of a disk cannot be 0. So that means tau 0 means alpha should be 0. Question number 7. If is the force, if F is the force, a vector is the force acting on a particle having position R, acting on a particle having position R, and tau be the torque of this force about the origin, tau be the torque of this force about the origin, then option A, R dot tau, means R and tau both vectors, always put vector sign, R dot tau not equal to 0 and F dot tau equal to 0. R dot tau not equal to 0 and F dot tau equal to 0. R, tau, F all are vector, so don't forget the vector symbol. Option B, R dot tau greater than 0, R dot tau greater than 0 and F dot tau less than 0. Option C, R dot tau equal to 0 and F dot tau equal to 0. Option D, R dot tau equal to 0 and F dot tau greater than 0. Question of vector actually. Which one is correct? Why? And why you are looking to him? You handshake with him, that's why I am asking why he is correct. Tell. Torque is perpendicular to R, and is it also perpendicular to force? Yes or no?
Yes.
Yes. So it is perpendicular to torque means R cross F. So it is perpendicular to both R and F. So dot product of torque with radius and force both will become 0 only. So option C is correct. Why you are getting so nervous? If one day you became a doctor and some patient comes and asks something and you are getting nervous, the patient will write on your prescription for your treatment some medicine. Okay, write down. When a mass is rotating in a plane about a fixed point, when a mass is rotating in a plane about a fixed point, its angular momentum is directed along. Option A, its angular momentum is directed along. Option A, a line perpendicular to the plane of rotation. A line perpendicular to the plane of rotation. Option B, the line making an angle 45 degree, the line making an angle 45 degree to the plane of rotation. Option C, the radius. Option D, the tangent to the path. Option D, tangent to the path. Not C. Which are options? First options is a line perpendicular to the plane of rotation. Option B, the line making an angle 45 degree to the plane of rotation. Option C, the radius. Option D, perpendicular to the tangent to the path. Tangent to the path. angular momentum is defined by the formula r cross p. So if a particle is moving in a circular path, let us consider. So this is radius r, this is the direction of linear velocity v, tangential velocity. So this is multiplied by m will give you the direction of linear momentum. Now extend this one, taking a cross product, L equal to r cross p. So put your hand here along the direction of r, then you rotate towards the direction of it is going towards the direction of p, then it is showing the direction of which direction? Coming out of the board. Out of the board means perpendicular to the plane of the circle. So option A is correct. Truly it is coming out of the board. So r is there, p is there, suppose x, y, then this L will be directed along z axis. So it will be perpendicular to the plane of rotation. Okay, not towards the center or along the radius.
Can we say that all axial vectors
Action.
along axis of rotation?
Torque similarly, axial vectors. Okay, next write down question number 18.
Previous one. Previous one.
Which one?
Previous question.
Oh, previous question number was 14. Now write down question number 18. A thin circular ring of mass capital M and radius capital R is rotating in a horizontal plane, about an axis vertical to its plane, with constant angular velocity omega, if two objects each of mass m be placed gently to the opposite ends of a diameter of the ring, of a diameter of the ring will rotate with an angular velocity. The ring will rotate with an angular velocity. Option A, omega, then start first bracket, m minus 2m, capital M minus 2 small m, divided by capital M plus 2 small m. Okay, I will write these options. Option A is omega m minus 2m by m plus 2m. Option B, omega m by m plus 2m. C, omega m plus 2m divided by m. And D, omega m by m plus m. Which principle?
Law of conservation of angular momentum.
Use conservation of angular momentum. Otherwise you cannot solve. See, only thing is that no external torque is applied, and in absence of any external torque, the angular momentum of the system will remain conserved. Okay, that's why they are saying gently placed. If during the placement, if there is certain force tangentially applied, then that force could create a torque. Okay, so if torque comes, then we cannot apply conservation of angular momentum. We can only apply when torque equal to 0. So in that case, initially what is angular momentum? Total mass m moving with angular speed omega. Now what is the total mass? M plus 2m moving with, say, omega prime. Then what is omega prime? One line question, nothing to calculate. See, it is a ring. So on the ring you can place only on the circumference. So in both the cases the distance will be r. So it will produce the same angular momentum. If it is disk, then the problem can be changed. That suppose at a distance r by 2, one particle is placed, another particle is placed at the boundary. Then calculation will change, because for the particle at the distance r by 2, it will not have the same angular momentum. It will be changed. So you cannot calculate all the particles taken together. Then you have to modify. Okay. So first of all, in mechanics topics, conservation laws you have to remember, and you have to apply carefully, whether the conditions is fulfilled or not for applying that particular conservation law. 3 conservation laws you will encounter in mechanics. One is conservation of energy, conservation of linear momentum, conservation of angular momentum. If you can apply this law, then you can solve the problem easily. Otherwise, you have to go for the dynamics calculation using Newton's law. And some problems, if you apply this conservation laws, will be more easier. Okay. So I think that in this visit I will discuss 1/4 of the topic, the problems and all these things chapter wise from 1/4 of the entire syllabus, and I think in 3 more visits I will be able to complete this type of questions from each and every chapter, such that doing particular questions there will be a revision of the theory already, because whatever we are discussing you will read this, and as a result your one time revision will be done. Clear? Now tomorrow's class we will discuss again rotational motion and gravitation. So in today's study session, all the study session, study rotational motion and gravitation such that you can solve the problem on your own